It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmer Junior Nice Coffee.
Hi guys, this video today is going to be just a bit of a lead-in probably to a design prac that you're going to be doing, or investigation prac. And this one we're going to be looking specifically is just around electroplating of copper. So if you haven't yet watched any of the videos on electrolytic cells, I suggest you do that because that'll give you a good background for what we're going to be looking at today. And the reason I say that is because electroplating is basically just using an electrolytic cell. Now, an electrolytic cell converts electrical energy into chemical energy. So what we're doing is we're using electricity to create non-spontaneous chemical reactions. So we've got these chemicals which sit there inside the beaker and they don't react until we pass an electric current through them. Okay, so it is an electrolytic cell. Okay. And therefore what that means is we're going to be having the one cell connected by a power supply. So when we're looking at electroplating of copper, what we've got is we've got our cell over here, okay? We've got our power supply up the top, okay? And then in here we've got two electrodes, and this is just a very simplified diagram of what happens inside electroplating, okay? But for our intents and purposes today, it's going to be reasonably straightforward. So what we've got here is we've got an electrode which is pure copper, and we've got an electrode which is the item that we want to plate. Okay, now in an electrolytic cell, the anode is positive. Okay, so this one over here is the positive electrode, and this is the anode. Okay, over here this is the negative electrode, and this is the cathode. Now, if you don't remember how to remember which one's the positive and the negative, and therefore anode and cathode, if you use that little acronym GAN-EAP, so galvanic cell anode is negative and electrolytic cell the anode is positive, that's how you can work it out. Again, that's covered in the electrolytic cells one, so go back and have a look at that if you need to. So in here what we've got is at the anode, and I'll actually swap over colours here, at the anode this is pure copper. So that one's our copper electrode there. Now the whole point of what's happening at the anode is where oxidation occurs. So the whole point of that is that we will have the copper losing electrons to form copper ions. Okay, so those copper ions, what they're going to do is they're going to go into our electrolyte here. Okay, and there's going to be copper ions inside the electrolyte. Now over at this electrode, this one here, okay, that's the item, all right, to be plated. Okay, now this item to be plated can be anything you want, but it's basically what you want the copper to deposit onto, because at the cathode we have reduction, and so the reaction that we have here is basically the reverse. We get copper ions picking up the electrons and forming solid copper. So our solid copper is deposited here at the cathode. Okay, so that's essentially what electroplating is. Okay, it seems very simple to begin with, but there's a number of factors that can influence the rate at which the copper is deposited and how well the copper is deposited over at the cathode. Okay, so we get an electric current flowing through. It causes oxidation here at the anode, all right, which is a loss of electrons. All right, so we get our copper, all right, losing electrons to form copper ions. Those electrons, all right, and the copper in here come over and they get deposited back onto the cathode over here, which is where reduction occurs. Okay, and the reduction over here means that the copper ions pick up electrons to form solid copper. So we get our copper moving from our anode over here over to our cathode, and whatever we've got here gets plated with copper. Now obviously over time what's going to happen is that our electrode's going to be corroded or eaten away. We're going to end up with no copper left, all right, and that's going to be deposited over onto the cathode. But the whole point of the investigation that you're going to be doing is to be looking at the factors that can influence the electroplating of copper. So what sort of things come into play and influence how well these copper ions here, which come from the anode, how well these copper ions are actually plated onto the cathode. So that's some of the things we want to investigate, and these are some of the things you want to consider when you're looking at factors that can influence it. So some of the factors that you'll want to consider when you're looking at things that will influence the rate at which copper is deposited over at the cathode. The first one, is probably the most important one, is the actual current that is supplied. Okay, so the current that's supplied to the electrolytic cell will determine the rate at which that copper is oxidized at the anode and the rate at which you get copper ions coming into solution. Now, if it's too low, obviously your electroplating will be very, very slow. So you might be inclined to crank up the current and get the electroplating occurring faster. However, as you increase the energy, what happens is that increased energy can therefore start to get involved with the electrolyte, and instead of copper getting deposited at the cathode, you can actually start having hydrogen ions, which, if you've got an aqueous solution of anything for the electrolyte, which you normally do, hydrogen ions inside the electrolyte can pick up electrons and form hydrogen gas. So instead of getting your cathode covered in copper, now what you're having is you're getting hydrogen gas being produced at the cathode instead. Now that can have a big impact upon electroplating, because these hydrogen bubbles can stop the copper depositing onto the electrode, and that can actually form a very impure surface. So current control is really, really important when you're looking at factors that influence the rate of electroplating of copper. Some other things you might want to consider, you might want to have a look to see if voltage is something that influences it as well. Okay, you might want to have a look at temperature, whether the temperature of the electrolyte has an influence. We know temperature affects the rate of a reaction, that it provides particles with more energy, which allows them to move faster, so they collide more often, and you get more particles that have energy greater than or equal to the activation energy. So we know that increasing the temperature does increase the rate of a reaction, but does it have an influence upon the electroplating of copper? You might want to consider that. Some other things you might want to consider is actually the nature of the electrolyte that you're using. So by that, normally, or certainly in my classes, when we're talking about using a certain type of electrolyte, we often use the sulfate. And the sulfate we use because that tends to be quite unreactive, and so it's normally the metal that's involved in the reaction that you want. But does changing the nature of the electrolyte, if you use copper chloride versus copper sulfate, does that make a difference? All right, so you might want to investigate that and think about that. Another one you might want to think about is actually the surface area of either your cathode or your anode, and does that make a difference? All right, if you change the surface area of the item that you're wanting to be plated at the cathode, does that influence the rate at which it's deposited? Okay, if you change the surface area of the anode that's dipped in the electrolyte, does that actually influence the rate at which copper ions come out of that into solution so they can be plated onto the cathode? Again, you might want to investigate that. Anytime you're investigating any of these though, you've got to remember that you've got to keep the others constant. So therefore, how are you going to keep them constant? What's the setting, like what voltage you're going to have, what temperature you're going to have if you're investigating current? So you need to maybe do a couple of trials in order to work out what will give you the best results. All right. They're probably the main ones I can think of. You might be able to think of a couple of others as well as you're brainstorming for your design practical. But again, like I said, if you need a recap on electrolytic cells, I really suggest that you look at that video, okay? Otherwise, just start thinking about how you would set this up, all right? Think about maybe what electrolyte you're going to be using, what you're going to be plating, all right? Does it actually influence, or does it matter what you're going to be plating? Can anything be plated with copper? All right, so a couple of things to think about there. Main thing though for this one, all right, make sure you understand the whole process of oxidation and reduction, the transfer of electrons, okay? Make sure you understand that cell diagram I had over here before. And as always, if you've got any questions, just ask. Thanks guys.